Good morning, students. In this lesson, we are going to see that continuation of 8th lesson, that salt hydrolysis. Very important for this topic because salt hydrolysis is very essential for our food manufacturing companies and some of the additive adding manners. Now we are going to see how the salt get hydrolysis depends upon the solute condition. Then I give the small recap about that previous section. What we have learned from previous video: buffer action and buffer solution, buffer index, and Anderson-Helmholtz equation. This four is fully depends upon the acid hydrolysis condition only. So you must aware of this four first. Then this video is very useful and very easy for your understanding. Now I'm going to give the small introduction and small definition about the salt hydrolysis. Salt hydrolysis is a reaction between salt and water to produce a acid and base or neutral solution. Acid solution can be made from the salt that or from the strong acid and weak bases. Okay, your simple understanding whether a salt and water is there, the reactor to give an acid plus base. Okay, wherever we are having this water and salt, the product is acid and base, and then you are having the chemistry practical also, the acid base titration. The same kind of things we are happening there. First you can understand the salt hydrolysis is reaction between salt and water. Okay, so hydrolysis is happening in the water medium. Hydrolysis is happening in a water medium. Let us assume you take a one bowl filled with your water and add a 1 kg of NaCl. But we know that is fully dissolved. As a normal person can say that what NaCl is fully dissolved from the water. But actually, as a chemist, you should know, you should give a clear explanation how much amount of the dispersion, how much amount of the ionization is happening inside the beaker. We are adding a 1 kg of NaCl. All the NaCl get dissolved and making a N plus and Cl minus ion. Okay, that what is the total quantity of L plus and Cl minus ion? We are going to identify this acid hydrolysis. Suppose the salt or acid we are adding to that water, whether there may be a influence to increasing a pH or decreasing a pH, otherwise that is maintaining a neutral pH for the preservation foods. That and all we are going to learn this video. Okay. Then salt hydrolysis. When acid and react with base, salt and water are formed. Okay, acid react with base, a salt and water are formed, and the reaction is called a neutralization reaction. So whether we are washing your hands, washing your face, what happening? We are using a soap as a base. Okay, then water as a solvent. What happening? That is completely neutralized your skin. That is only completely neutralized your skin. What happening? The neutralize your skin means the skin is protected. The skin is protected. Supposed to be you are not washing your faces and is clearly means what happening? The basicity or acidity will be increasing due to the emission of the sweating. Okay, suppose a n number of sweating will be happening, all the salt particle will coming and deposit your skin. The skin hair holes will be completely closed. Then afterwards you can't never clean that skin properly means that hole will be black. What happening? The sweating particles settled on inside, we can get different types of diseases. So you can understand simply, salt is the base. A soap is having a property to remove unwanted dirt and oil spots on skin. The same kind of thing, the acid react with base and producing a salt plus water. That water is called salt plus water. That is called a neutralization reaction. The salt completely dissociated in aqueous solution to give their constituent ion. Take NaCl is one of the common example. NaCl. How they are completely dissociate? Na plus Cl minus. Okay, that is the constituent ion. The constituent ion completely dissociated. The ions so produced are hydrated in water. This is in water medium. This is in water medium. Hydrated water is nothing but the Na plus and Cl minus ions in water medium. In certain cases, the cation anion both react with water, and the reaction is called acid salt hydrolysis. Okay, here the salt get neutralized, then water is having a H2O. This water is having a H plus and OH minus. This also going to influence and making any reaction of this compound means that is called salt hydrolysis. That is called salt hydrolysis. This video we are fully going to learn how the salt is hydrolyzed with the help of the water. Then I taken here one salt, strong acid and strong base. I take the strong acid and strong base. Instead of I taking one, I take NaOH is a strong base. Nitric acid is a strong acid. How they are going to dissociate it? Na plus and OH minus, H plus and NO2 minus. Okay, the H plus and NO2, NO3 minus ions are constituent ion for NaOH. This is a reaction sequence. This NO will be going to attack here. This OH is going to attack here. Okay, what happening? We are finally get NaNO3 aqueous medium plus H2O as a water liquid. Okay, the salt NO3 completely dissociated in water and producing a Na plus and NO3 minus ions. Okay, how they are going to dissociate Na plus and OH minus ions in aqueous medium, that is a water medium. So water dissociated to small extent. Water dissociated to small extent. This water dissociated to smaller H plus and OH minus ends. H plus and OH minus already there in your chamber. Otherwise, the byproduct also we are getting. What happening? Product and water mediums are same. So 100 H plus is there in your medium. Finally, in this reaction also we can get 100 H plus. 200. The same time 100 OH minus is there in your medium. The reaction we get 100 OH minus. Okay. Finally 200 H plus, 200 OH minus. That is said to be a since H plus is equal to OH minus. Water is a neutral. Okay. So it's not give any reaction with this type of salt again. So finally we said the condition of this medium, it means there is no hydrolysis. That means there is no hydrolysis after. In such a case as H plus and OH minus ion is equal means the pH maintain their neutral medium. Suppose this pH is 7. This pH is 7. Okay, this is the important topic for preservating your foods. Okay, suppose in another one case is there, that case is totally different. We took a strong acid and strong base. The both are strong. Another video I can take one strong and one weak. See, the salt hydrolysis strong acid and weak base. First you can understand strong base. Sodium hydroxide is a strong base, I said earlier. Then weak acid, acetic acid is a weak acid. Why we say acetic acid is a weak acid? See, ability to donate a proton or ability to donate H plus ion, small extent. So only we said this is a weak acid. What happening? This Na plus and OH minus. This COO minus and H plus. For see this plus and coming and attack here, we get a CH3 COO Na. Then this H going to attack OH, we get a H2O. Aqueous solution in CH3 COO Na. Again they are going to dissociate it, forming a CH3 COO minus, then Na plus. Okay. So the CH3 COO minus is a conjugation of acetic acid. Conjugated of acetic acid. Then this is not reacted. So this is producing a unionized acid. That is producing a unionized acid. There is no tendency for Na plus to react with OH minus. Okay. So once they are making a constituent ion, then after is not able to attack with the OH, is freely moving ion. So only I said unionized acid. Okay. Then again the CH3COO in aqueous medium in water, what happening? H plus HOO. This HO going to attack here, we get a OH. Like this they given the example. This OH from the chamber. This OH from the chamber. You can understand we are having a chamber. The chamber filled with water. the water added by the sodium hydroxide and acetic acid, we get initially this reaction. Afterwards, the ions are, once they are making this types of product, this product again going to dissociate to forming a CH3 COO minus and Na plus. What happening? The CH3 COO minus is nothing but a conjugated base of pair of acetic acid. So the free acetic acid is there. So in the chamber is containing water, that water is containing H plus and OH minus. That H plus going to attack with this acetate ion, we can get the acetic acid get regenerated and OH minus ion regenerated. What happening here? The OH minus ion concentrated will be greater. The OH minus ion concentrated will be greater because the more number of OH get formed. The more number of OH get formed because the medium is water medium. So pH is greater than 7. pH is greater than 7. pH greater than 7 means that is base. That is base. We know, we are assumed this is a base because the OH concentration will be very high in water medium. Let us find the relationship, equilibrium, find the relations between the equilibrium constant of hydrolysis reaction. We are going to find the hydrolysis constant Kh, hydrolysis constant is Kh, and the dissociation constant of acid. So instead of helping with hydrolysis constant, how we are going to find out dissociation of acid? This is the final equation for our base concentration calculation value. Okay, this with the helpful of this equation, we are going to find out the pH of the sample. So how we are going to find out the pH of the sample? We know that concentration of H plus power of hydrogen ion, power of hydroxyl ion concentration is equal to 14. Okay, pH is equal to, we don't know about that one, hydroxyl ion concentration. I taken here P power OH minus, okay, is equal to 14 into, this is nothing but minus log of acid, sorry, salt by acid or base, acid or base. Either here we want to base, so only I make an salt by base. Okay, so log of minus log of salt by base. What happening? Base is nothing but OH minus ion. I am simply substituting here. This plus into plus, minus into minus plus log of OH minus. Okay. Then 14 into log of this OH minus ion. We can remember OH is equal to, according to the strong base and weak acid combination, OH is equal to root of KH into C. So I am simply substituting here. Instead of removal of this square root, I can add 1 by 2. Okay. We know that acid hydrolysis depends upon the condition of water medium and whether they may be acid or base. I can written here also. Okay. Water. The water medium is there. Hydrolysis depends upon the water medium. So we want a base calculation. I adding a acid value here. So power of hydrogen ion concentration is equal to simple substitution of log in coming to A by B. Sorry. Log 1 by 2 is coming on front, log Kw plus log 1 by 2 log C minus is coming under denominator. I am substituting the minus from here, is coming a numerator. Okay, 1 by 2 log of Ka, 1 by 2 log of Ka. Since we know that one, this is a formula I can derive already from the pH calculation. Water dissociation constant is equal to 10 to the power of minus 14 at 25 degrees centigrade. So of log of Kw is equal to of into log of Kw value I am substituting here. Okay, this value I am coming on here. What happened? Minus 14 divided by 2 into 1. The value of log A, log base 10 power 1 is equal to 1. Okay, simple multiplication, we get a minus 7. Okay, then this pK is equal to pKa. We are already find out this one also for the log value calculation. This all I am going to substituting this equation. See, 14 minus, what is the value of K log Kw? 7. This value is 7. Then remaining concentration, instead of this one I can add Ka. Okay, then 7 plus of pKa plus log C. This is the final equation for calculation of pH pH calculation for the strong acid with strong base electrolyte. Okay. Then the another example, salt of strong acid and weak base, another composition. Okay, first you can understand weak ammonium acetate. So ammonium acetate salt, how they are going to dissociate acetate ion plus ammonium. In this case, both cation NH plus and anion have a tendency to react. So in this case, both cation NH plus NH4 plus and anion CH2 having a tendency to react with water, because so water having a two polar substances, nothing but H plus and OH minus. These ions going to attack here and this ion going to attack here. Okay. Finally, water will get attacked here. We get acetic acid and OH minus, and ammonia get ammonium hydroxide plus H plus. The new nature of the solution depends upon the strength of acid or base. Ka will be greater than Kb. Then the solution is acidic. pH greater than less than pH is less than 7 means the Ka less than Kb. The solution is basic. So the pH less than 7 means the solution is acidic. Ka is equal to Kb means the solution is neutral. So the pH more than 7, that solution is called basic. The pH more than below than 7, that is acidic. The pH should be 7, that is called a neutral solution. The relationship between the dissociation constant of Ka and Kb and hydrolysis constant is given by following expression. Okay. See, here all are equal to dissociation constant of water. Dissociation constant of water, whether the acid and base and hydrolysis. In this condition only is coming under these types of reaction. So the water value is like Ka minus Kb. This is a simple representation of, you don't worry about that calculation. You can understand this is simple representation of weak acid and strong base. Weak acid and strong base. Okay. Then we are going to read the solubility product. Solubility product is fully depends upon the nature of the compound. Fully depends upon the nature of the compound. With compound means nature of the salt. The solubility product of compound is defined as the product of molar concentration of the constituents ion. Molar concentration of the constituents ion, each raised to the power of the stoichiometric coefficient in balancing equation. Balancing equation depends upon the condition of increasing the pH. So, to understand the precipitation, let us consider the solubility equilibria that exist in between the unassociated sparingly soluble salt, its constituents ion in the solution. Okay, you can understand. You take a 10 gram of NaCl. That is form Na plus and Cl minus. What happening here? This is fully dissolved. Suppose we are taking like this type of sample, lead chloride. It's having a property to settle down the bottom. This is a sparingly soluble salt. This is a sparingly soluble salt. Like this salt, type of salt, we are going to helpful to find out how much amount of the lead will be dissolved, how much amount of the chlorine will be dissolved in your chamber. This is helpful to find out in the solubility product. The solubility product is nothing but the stoichiometric coefficient. Stoichiometric coefficient means lead chloride is there, Pb plus Cl minus. Okay, Pb plus Cl minus. Suppose chlorine will get 30 grams and lead will be dissolved in 10 grams. But normally we should say this is dissolved, but on the stoichiometric coefficient 10 into 30. 10 into 30. How we are find out this ratio? With the helpful of this equation. Okay, with the helpful of this equation. Then we can summarize the equation. The ionic product greater than the solubility product. Precipitate will occur. The solution gets supersaturated. The ionic product less than the sparingly salt. No precipitant. The solution get unsaturated. The solubility product and then equilibrium equal means ionic product is equal to solubility product means that is a saturated solution. The saturated solution best example is salt water combination. Salt water combination. The above the water and calcium hydroxide, the pasty mass will be obtained with certain time. It will be saturated. After the few hours it will settle down. The ionic product, the precipitation will be occur. The solution is super saturated. So we can give some amount of the heat to convert the product as a super saturated solution. The determination of solubility product from the molar solubility. So molar solubility means the mole ratio also having a some of the influence to making a solubility. So the mole ratio, you take one example, 10 moles of sodium hydroxide we have taken, then 10 moles of water we take. So what is the product we can get? So this types of question will be answered this molar solubility solved. Okay. Then the solubility product can be calculated from the molar solubility. The maximum number of moles of solute that can be dissolved in 1 liter of the solution. This can be dissolved in 1 liter of the solution. For the solute XMYM. Okay, XMYM, and this is under all coming under the moles. Okay, the solution we can get here different ratios of moles. From the above stoichiometrically balanced equation, we have to come to known that 1 moles of Xm and Yn solution. Okay, then dissociated to furnish M moles of X plus 1, then N moles of Y plus M. If the S is molar solubility, then Xm and Yn is then. So whether you can simply understand, and depends upon the mole ratio, the solubility get increasing. Depends upon the mole ratio, the solubility get increasing. Just you can understand the stoichiometric balance equation word is very important for the determination of molar solubility. Then I'll give the small recap of this section. Hydrolysis, combination of salt hydrolysis and pH calculation. Thank you, students.